Hello, everyone, and welcome to our webinar, How to Build LLM Apps That Can See, Hear, and Talk. My name is Matt Brown, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a single story event, heads up that we sponsor regular webinars and events demoing data, AI, and engineering use cases and technologies. And the next big thing that we're looking forward to is the real-time AI conference on October 17th at the Chase Center in San Francisco. Today only, Single Store is going to be sponsoring discount codes for this audience only. You can grab your $25 ticket right now. It's usually $199. So all you need to do to get that discounted ticket is go to this bit.ly link that's on your screen. It's bit.ly AI conference webinar discount. I'll put that in the chat in a minute. You could also take a photo of that QR code that's on your screen or a screenshot of that QR code. And all you'll need to do is enter Single Store 25 during checkout, and you'll get that discount code. So I'll put that in the chat in a minute. But okay, we'll leave that on the screen for a moment while I talk a little bit more about today's plan. FYI, we have fantastic technical experts who are going to be joining our Zoom Q&A. They have a good grasp of all the technologies that are involved. They're ready to answer your questions interactively. We will try to get to as many of the questions as they come in interactively. And I will also flag a few for the live Q&A at the end of today's session. We'd also love for you to try today's technology. In fact, anyone who tries this today will be entered for a chance to win brand new AirPods Pros. If you click to the next slide, you'll be able to see the URL for this. All you need to do in Madhukar, if you click to the next slide, we can see that. All you'll need to do is click this link or type it into your browser. I'll put it in the chat in a minute. It's the bit.ly See, Hear, Speak raffle. And you can also take a photo or screenshot of that QR code. That'll take you where you need to go. All you need to do is log into Single Store. There's a free trial if you're a new user, or an existing account if you're already a customer, or an ongoing trial. Anyone who's on this and who clicks that link, comes in there, is going to be eligible. We will announce a winner of those AirPods by the end of today's session. So you'll need to click that over the next session today. So let me introduce our speakers for today. Madhukar Kumar is our Chief Developer Evangelist at Single Store. He originally has a background in software engineering, and more recently, he has led product marketing and product management teams in the cloud data industry. And then I'm also excited to introduce David Lee, who is a cloud solutions engineer at Single Store. His job is to help Single Store customers employ technical solutions to solve complex data problems. He has experience with data science, cloud architecture, and multiple types of machine learning and AI use cases. Welcome, Madhukar and David. Madhukar, I believe you have the floor first.
All right, thank you so much, Matt and David. I'm really excited about this, as I've been yelling about this to all my friends and also on LinkedIn and Twitter as well. So before I get any further, I wanted to go back to the conference a little bit. So 2 questions we get every time in any webinar is this recorded and will it be shared? The answer is yes. And 2, for this conference that you see, is this going to be in person or virtual? For now, it's in person for anybody who is in San Francisco and can make it. I would highly recommend it because the entire day we'll walk through how to build an enterprise LLM app with Single Store, of course, but also all the other production-ready tools to make it really, truly enterprise-ready. So if you're looking to become an LLM developer all the way from conceptualization to building it in production-ready manner, this is for you. And if you are a student, we'll give this ticket to you for free. There are very few limited seats, so please register. And then at a future date, we'll try to take this to the road. So this will be available. We will be doing this in Asia as well as in Europe as well. So today, what I wanted to do was just kick it off first with the really amazing, or I should say expected news that came out this week, which was OpenAI announced that ChatGPT can now support both audio and video. That means if you have the app on your phone, you can speak to it and you can also upload pictures to it or use your camera. And ChatGPT can help you with your question through both audio and video. So this is something that has been expected for a while, but at the same time, now this really opens up a few opportunities of making AI real time. And I'm a big fan of Avengers as well as Iron Man. So as you would know, this gets us closer to what Iron Man does with Jarvis, where you're literally speaking to it and you're showing it images. And then if you combine it with your virtual or visual glasses or AR glasses, whatever you want to call it, then this really starts to amplify who you are and what you do. So interestingly, I would also mention that Meta or Facebook announced, I think yesterday or day before, that they now have these new Ray-Ban glasses that can immediately take pictures as well as it can view what you're viewing and then overlay with overlay about that architecture if you're looking at it, or even certain pictures of certain things. So now we are headed into the next phase of AI in my mind, where it is important to have a data strategy that also considers audio and video. And audio video is not trivial if you're already in the data business. So the first thing, of course, that we have been talking about for months and months is, okay, ChatGPT is great, but it is frozen in time in terms of the data. It has been frozen into time from the data that has been generated or been trained on till September of 2021. So one big drawback is if you have images or if you have audio file which is sitting inside your own enterprise network, which is private, ChatGPT doesn't know about it. Irrespective of what LLM you use, they didn't have access to it at the training time, so they don't know about it. So typically you can give that information to the LLM in one of three ways. You can either retrain the LLM, which is hugely expensive and time consuming. Second is you can fine tune it, but fine tuning is to change a behavior, not to give additional knowledge. And the third one, which has kind of become a de facto core standard, is what I call as in-context learning or real-time learning or retrieval augmented generation, which is more popularly named these days. So retrieval augmented generation is really when if somebody asks a question that the LLM doesn't know about, you literally go to your corpus of data, audio, video, whatever it is, then you do a quick search on it to say, what is the quick match between what the user is asking and my data? And then you create what is called a context. Context is, here's a book, literally a very thick book of all my data. It includes audio, video, and then you hand it over to the LLM and say, hey, using your amazing skills, now read this book and answer this in real time. And real time really is split seconds. It doesn't mean 5 seconds or 10 seconds, because if you're talking about autonomous driving or even embedding these in glasses and such, you literally need to curate that petabytes of data that you have in your enterprise in 2 milliseconds or 200 milliseconds, right? So that's where the world is headed. This is what we have been seeing everybody implement. And if you double click on the overall architecture, and this is what we'll be covering in depth in our Single Store Now conference on October 17th, what you would see is that it's a typical 3-layer architecture, which is very similar to the human brains in many ways. You have the UI architecture, or I call it the effectors and the receptors. These are conversational UI. Now it could be glasses, it could be a phone, it's your browser plugin, and basically anything that's audio and video interface. But also it could be, if you're on a computer, it could be just regular UI components that you use. One of the good libraries over here that I've seen emerging is the Versal AI SDK. I would give it a try. I've been playing around with it, and there's a lot you can do with that. Then the second piece is very similar to what is a human prefrontal cortex, and that's your decision-making unit. And this is where I think not just one LLM is going to win, but it's an ensemble of LLMs. And some of them are fine-tuned for specific tasks. In fact, what is really interesting is back in the day in 2003, I had written a paper for my master's thesis on multi-agent software engineering, which was a bunch of different agents collaborating with each other to do certain jobs. And now we are seeing this with libraries like LangChain, where you can create tools for what your LLM application can do. You have a bunch of tools to chain different LLMs, where be it commercial like Claude 2, or it's open source like Llama 2, and so on. And then you are doing or coordinating all of this, but in a production-ready manner, where you're looking at the response times, you're looking at the evaluation of whether your contextual data is correct or not, and so on. And then the last piece, which is the most important piece, is the data itself. And in that data, you're not just talking about vectors only, you're talking about SQL, structured data, JSON data. Maybe you're pulling in data from Slack, from PDF images, your Google Drive, or even customer support tickets, which again, this is data or corpus of your enterprise data that is not available to LLM when it was trained. So if I double click on the last one, of course, because I work for Single Store, and this is one of the reasons why I work for Single Store, is I love this space. This is the infrastructure space. Think of it as electricity. Think of it as maybe your internet connection. So it's invisible to you, but the only time when you notice that you don't have data or your database is not working is just like electricity when there's a blackout, when you lose electricity. So it is that most important invisible layer that is powering all your LLM application. And if this is not really under control, then your LLM application is not accurate, it is slow, and most of the time that then just becomes unusable because mostly a gimmick. So what we are building in terms of Single Store is this architecture. And I won't get into the details of it. If you're interested, drop a note or a comment, and we will very happily do another webinar. We have started to do this like once or twice a week. And we have started to listen to what users want to hear more from us. So if this is one of those things that you want to do, then absolutely let us know and we'll do another webinar. But in this RAG architecture or in-context learning architecture, one of the things that you have to start considering now is when you're doing a semantic search to curate that data that you have in your enterprise, how do you do the search? And initially, a few months ago, it was all about vector databases. So you have vector libraries like Face or Annoy from Spotify, Faces from Facebook or Meta, or NSLB, which is supported by Google, and so on, or vector-only databases that we started to see. Like there's a bunch of these like Superbase and Chroma and so on and so forth. But what about audio and video? And how often do you vectorize that data? How do you keep that data fresh? Like if your customer support tickets are coming in right now, then how do you vectorize it at that time and then match it to what the user is asking? How do you do all that? So I'll give you a perfect example of what we do at Single Store with one of our customers, or what one of our customers, what is the use case for audio and video with Single Store? What they currently do is help situations like Amber Alert. And within Amber Alert, what do? You maybe have bits and pieces of information where there is a child missing, the car is color white, maybe it's a Tesla model and it's model 3, and it was last seen in a known location, and maybe somebody took a picture which is kind of a fuzzy of that person. So in the feed of cameras that are coming in across maybe hundreds of thousands, what this customer does is you can use Single Store to do one SQL query which says, show me everything that has car make equals Tesla, color equals white, license plate includes the letter K, and by the way, do a dot product or a semantic search with this image. And all of this happens in a millisecond. So why is that important? Because now, as you would see in this demo and example that we'll show today, that you are actually processing images, you're processing audio, you're curating the data, not in seconds, but in milliseconds, so that then you hand it over to your LLM, which then applies its skills and knowledge, and you respond to it in a few milliseconds, because in these cases, milliseconds matter. So what we are trying to do is make that a reality for all our customers. So we call ourselves a database that can transact, analyze, and contextualize data in real time. But in reality, the way I, kind of make a joke about is if MySQL or Postgres and Snowflake had a baby, that would be a good looking baby like single store. So we do all the analytics works, which is columnar data. We do all of the transactional data, and we also have vectors, and we do it in split seconds. So it's not a batch related job. It happens in like quick seconds. So we have very large customers, which I'll quickly flash in one of my slides, that use us for production business requirements. So we're talking about maybe Palo Alto Networks that uses single store for all fraud detection, or actually all security incidents. We have very large banks that use us for real-time investment decisions. We also have customers who use us for fraud detection and fraud prevention, credit card industry. And we have a bunch of marketing analytics company that use us where they have taken 22 hours of batch work and converted into 18 seconds. And this is a good example of LiveRamp, which is it is the largest identity graph database that they've built on top of single store with petabytes of data. So the thing to note is it's row-based, it's also columnar-based, and it's vector. So row-based would be anything like Postgres or MySQL, except 100x faster. Columnar means it's like Vertica or Snowflake and so on. Vectors means it is just like any other vectors like Pinecone or Milvus or so on. But it also helps with, it is also compatible with Mongo APIs. It does SQL. It has time series, it's a geospatial, and you can run it as a Docker instance. You can run it in a hyperscaler like AWS or Google, or even Azure, or you can run it in hybrid as well. And so again, I've spoken quite a few use cases about the customer, so I'll skip that. The thing that makes us different, because this is a question that comes quite often, is how is it that we can do both columnar as well as row-based data in milliseconds, whereas maybe other batch-related analytics databases or data lakehouses cannot do. And the reason we can do that is because we've been around for about 8-10 years. We have several large customers. About 60 to 70% of our customers are Fortune 100 companies. And we were known as MemSQL. There were only 3 in-memory databases a few years ago, Memcache, Redis, as well as MemSQL. And MemSQL was us when we figured out a way to take that row-based data, move from memory into SSDs and NVMEs, and then finally into cloud object storage, but still maintain that speed because of this architecture in a single storage. We patented that technology and called it single store. Funnily enough, our competitors are trying to do the same thing now, and they call it a different name, but the store still remains. And then the other thing that is very different about us is because we do a very fast commit in memory. That means when we ingest the data through 5 lines of code, which is called pipelines within single store, you can query it while the data is in flight. So this is for extremely fast ingest from Kafka and so on. So that's the next webinar that you would see. There are a few recent announcements that we made. I will not spend too much time on it because this is not a pitch for single store. What I will talk about, though, is that we added a compute layer or a layer of intelligence on our database with Python notebooks. We call it, of course, just notebooks. And David is going to show you how he has created the multi-model or LLM app that can see and hear with an example within a notebook. It gives you Python. So as you can see in this example, you can go out and bring in data. You can assimilate data from multiple data sources. You can use libraries like Pandas, TickToken, Plotly, Matplotlib, as you can see. And so once you sign up for single store, either today or later on, you can go into the notebook you can go to singlestore.com/spaces, and you will see tons and tons of examples that you can just use. These are some of the things that we do, which really makes us not a vector-only database, but more of, I would call a contextual databases, because all the things that I just mentioned. And the key thing that is very, very unique about audio and video application is you have to mix and match your search and data. So within single store, for example, you can do a semantic search, and we have had this since 2017 when the first transformer paper was written by Google. And there are vector functions that you can use directly inside SQL. So one of them is dot product, which tells you the semantic match between two objects. And those objects could be audio, it could be video, it could be text, it could be JSON as well. And we store it using our own functions that allow you to pack that data into a binary object so you use less space, yet the processing speed is spectacularly in a few milliseconds, as we will show today. And you can mix and match the data, of course. And with Python now, or the notebooks that we'll see today, you can even talk to LLMs, and you can bring that LLM locally if you so choose to, do because of privacy. And so you can start to build that three-layered architecture that we just talked about. So with this, enough talk, as I would say, let's hand this over to David, who is the star of the show today, and he's going to show us how he built a Jarvis-like system using single store. So I'm going to stop sharing, David, so you can share your screen, and then I will hand it over to you.
Thank you very much for the introduction, Madhukar. Let me go ahead and share my screen, and let me know when you can see it.
Yep, we can see it.
That's perfect. All right, so we have a lot to cover today, so let's dive right into it. I have data that's stored in SingleStore, and I'm connected to it using SingleStore's Python connector. I'm leveraging OpenAI embeddings as well as LangChain to power this app. And I can ask questions that will query the database and return the answers in an interactive way. I did a similar webinar on this a few weeks ago, and since then, I've made a lot of improvements. Let me show you what I mean. What was the highest and lowest opening price for Amazon in the past year? It's taking a little bit. Let me see here. All right, so let me go ahead and actually reopen this app here because these things happen in demos. Let me see here. There we go. All right, let's try that again. What was the highest and lowest opening price for Amazon in the past year? There we go. All right, it's returned. Just took a little bit that time. Great. Let's ask it a few more questions.
That volume's pretty low, David. I don't know if you can turn that up at all.
Sure. Let me try that. Just hold on one second. It sent multiple requests, so just give me a moment while I reset this here. All right. So I raised the volume, so let me know if you can hear this a little bit better. How many tables are there? Awesome. So it's it's making an API call. There we go.
Company info, embeddings, news sentiment, and stock table.
Hopefully the sound is a little bit better. Let me know
Yeah,
if it's
that
not.
volume's a little better. It's
Perfect.
enough that I could hear what it's saying.
Great. Can you tell me the number of rows in each of the tables?
There are 12,841,572 rows in the stock table, 225,344 rows in the news sentiment table, 48 rows in the company info table, and 31 rows in the embeddings table.
Perfect. So we can get a little bit more information about the table. Let's ask it one more question. What was the average stock price for Amazon in the past 2 months?
The average stock price for Amazon in the past 2 months is $135.94.
All right, so a little bit of technical difficulties, but that's pretty much what it is. I'll kind of show you how I built it. So for those of you that had a chance to connect your data with LangChain, might have seen this process take a lot longer to return. And it takes even longer without even adding the voice recognition and the speech part. So I'll go into some of the techniques I use to achieve what I created here in this session. All right, so as Madhukar had mentioned earlier, multimodal LLMs are really the rage today, especially with the release of OpenAI's new image model. They can talk to and add images and ask questions on your image. It's really pretty amazing. Being able to do this on your own data is becoming even more important. And I believe SingleStore is well positioned to address a lot of these use cases. What I'm going to do is first show you the SingleStore customer portal UI. Basically, you have different instances of compute. You have your storages and databases, and they're separated. You also have compute separated with compute, which gives you a lot more flexibility in how you want to set up your data. The notebook that we're going over here is actually available in our spaces here. It looks like this, and Matt can share it with the chat. And basically, if you want to try this notebook yourself, you can go ahead and sign up here and try this notebook for free. All right, so once we are here, there's a notebooks section where basically I'm able to see the different notebooks that I've had, and I've already have my notebook open. So I'm just gonna go over to this piece here. And the demo architecture looks like this. Basically, I have a couple of different data sources, from using the request library, and this is going to be news feeds, stock ticker quotes, as well as company data that's going to be stored into SingleStore. And basically, I've set this up so that when you're asking questions on the front end, you'll be able to create vector embeddings on your question, and then ask it on compared to other vector embeddings on the table, and it will query SingleStore directly, which will then output it back to the device in using speech. So let's just go right through this notebook here. But actually, one thing that I would like to show you also is going back to the cluster here. Just want to show you something really cool. I thought it'd be really cool if we go ahead and build everything from scratch. So I'm actually going to drop the database of the demo, and we'll build everything from the ground up. So for those of you that are new here, can just basically follow this along, and you'll know like exactly what to do. So over here, we're going to create our database. I've connected to my workspace up top here. My workspace is called BP Mongo enabled. And I'm just going to go ahead and run this cell, which you can make it a SQL cell and run SQL directly. And this will create our LLM webinar database. And once that's created, what we could do is just select our database. and create our tables. So we have 4 different tables: stock table, new sentiment table, we have a company info table, and then a table to store our embeddings. So we're going to go ahead and create that. And we can see that these tables have been created. Next, we're going to install some packages. This is going to take a little bit of time, so I'm going to run them now. And basically, for the text to speech, I'm using an API called 11 Labs. You can switch out different libraries, whatever you would like to do. But in this case, I'm using 11 Labs. I think they have a very nice speech, as well as LangChain and the single stored Python client. And once these are loaded, I'm going to enter my API keys here. The first one is going to be for Alpha Vantage, which is where I'm getting my stock ticker data. And then I'm going to enter my OpenAI API key. And then our 11 Labs. And once this is set up, we'll go ahead and bring some data in. So I'm going to set up the single store connection just using a simple connection URL. This is already built into single store, so it's very easy. But basically, this is going to have the host information, the database information, and it's all going to be able to easily connect to single store. And we have a list of just 3 tickers for this demo. And we're going to use the request library and start ingesting some data. So we could see it already started loading some data for Tesla. This takes a little bit of time. So what I'm going to do here is just go over what we did here. So basically, I created a function to indicate how many months of data I want to get. In this case, it's going to be the past 2 months of data. And then down here, we have a bunch of just the data cleaning to make sure this JSON that's coming back from the Alpha Vantage API comes clean and broken up into the different columns when it gets ingested into single store. Down here, I indicate which table I want to store the stock ticker results. And I have my insert, just a normal SQL insert statement, and pass that into the single store Python connector. And once that is all set, I can see that, here's what the data looks like. It has the time of the ticker. It's every 5 seconds in intraday data. It has the open, the high, the close price, as well as the volume for that day. The total number of records on the stock table, in this case, is 24,000 records. And I'm going to do the same thing for company data as well as new sentiment data. Since it's only 3 tickers, that came back really fast. We can see that, here's an example of one of them for the Amazon ticker. It has a description, as well as a lot of good company information that I could then ask it later on. And we're also going to bring in the new sentiment data, and it's just the same process. So we brought in data live, and basically we were able to easily do that right within single store. We can see that the new sentiment table has roughly 2,600 records, and now the data is in. All right, so we did this portion. The data is in single store. The next thing we want to do is create our large language model agent using LangChain. So let's do that. Great. So we're going to create our agent executor here, and basically we're telling it which tables to include, the temperature of the LLM, which is going to be like the creativity. And in this case, I want the answers returned not to be creative. I want it to give me accurate answers. That's why I'm going to keep the temperature as 0. And if you wanted to increase that, you would increase that that amount. So we're creating that agent, and it's basically using the instructions on how it's going to behave with the model. We're also going to set up a function that's going to process user questions. And basically, when I ask the app a question, it's going to create the vector embedding. And it's also going to check if a similar question has already been there. As you could see, there's a semantic cache layer here. I actually wrote a blog about that, Matt. If you want to share that with the chat, that'd be great. But basically, the idea is the questions that you ask especially in like this, chatbot scenario or like an FAQ on your web page where users are going to be asking a lot of similar questions. There's no need to make extra API calls to the model, and which is going to take a lot of time going through the agent chain, as well as cost just for the larger number of embeddings that you need to make. So I'm going to run a check, and basically if the vector that I'm sending single store, if it's very, very similar to a vector that already exists, it's likely the intent of the question is the same as a question that has previously been asked. So I don't have to make that API call, and it'll just return the answer of a semantic similar question. And this is called a semantic cache layer. In this case, I set my similarity threshold to 97%. So if a question is 97% similar to a previous question, it's going to use that answer of the previous question. All right, so we're going to go ahead and set that up. And basically, if a question is not similar, it's going to run through the normal agent executor chain, which is going to take a little bit more time. It's going to make that OpenAI API call to get the answer. All right, so to test this, I set up two very similar questions. Describe the database and describe database are not the same, but they basically mean the same thing. So we're going to go ahead and test the semantic cache layer on those questions. And we're going to process describe the database. And I outlined in my function the time it takes for each of the steps. You can see here the check for any existing questions. It took 56 milliseconds. It found that there's no existing rows. So it's going to run the agent executor, which in this case took 1.8 seconds. But this, in this case, there's it was a very short question. If you have a longer question, it might take a little bit more time. If you have a lot of rows, it might take a little bit more time checking the number of records. But you could see that it returned an answer in under 2 seconds. And we can see the answer is indeed in the table. So the question we asked was describe the database, and it shows that it contains company info, embeddings, news sentiment, and stock table. Based on some prompt engineering, I was able to output the SQL as well, which is show tables. Okay, so now that we've asked the first question, it is now in the database. Also, that query plan is stored in single store's plan cache. So if you're asking it a similar question, which is the check for any similar queries, which is going to be right here. So that's right here, right? This query right here, that's basically taking the embedding, searching it. That's going to be stored in the plan cache, and it no longer needs to compile that query. So when I run it a second time, it should be quite a bit faster. And take a look at that. I got the answer, the check. I got the answer in 162 milliseconds. The check for any existing rows took only 2 milliseconds, taking advantage of that plan cache, and we were able to return the answer to the same semantic question: describe the database as well as describe database. So you could do that semantic cache layer right in single store. You don't need a separate caching layer for these use cases, which is really great because then there's no data movement. It lowers complexity as well as reduces network latency. So awesome. We were able to build our LLM. We tested that works. We added the semantic cache layer. Now let's go ahead and figure out the voice and speech piece. So in that case, we're using 11 labs. And what I'm going to do here is we're going to add a voice. I'm just going to use the first one that they have. This is the Rachel voice in their library. And what I'm going to do is just pass the answer to the previous question, which is describe the database, into the 11 Labs API. And when we do that, we're able to output a MP3 file, which is then stored in this directory. We can see that the MP3 is right there, and then we can play it.
Contains the tables, company info, embeddings, news sentiment, and SQL query used to get the answer? Show tables.
Awesome. So we got the speech piece taken care of, and we also have a output file, right? The next piece is leveraging speech to text, all right? So I have here basically using OpenAI's Whisper model to transcribe the output that I just created here, just to see if that works here. So, and it outputs the database contains the tables, company info, embeddings, news, sentiment, stock table. It's working exactly as expected. So the idea when I was using the app is when I speak to the UI, it's using the OpenAI Whisper model to transcribe it into text. And then it gets embedded into a vector, which then gets passed into single store to check if there are existing rows. And then it gets an answer either through the semantic cache query or through the agent executor, and it outputs that result using 11 Labs voice to return back to me. All right, so we were able to essentially do all of these pieces right here, but in terms of like the multimodal LLM piece, like there's also like images as well. I don't have that today in my UI that I demonstrated earlier, but I could actually show you how to achieve this. So let me go ahead and show you that. All right, and for this example, I'm going to ask the database a new question. All right, what are the most recent news articles for Amazon where the topic relevance score is greater than 90%? All right, include the URL, time published, and banner image. All right, so that image is going to be what we're going to use here. So let's go ahead and run that. This is a new question, so it's going to run through the agent executor. You can see here that we did that check. The similarity score was under 70%. So the action to take is it's deciding to then run the agent executor. Okay, and when that completed, we actually have the answer here. And we have here the SQL query that's outputted right here. So let's go ahead and test that to make it a little bit more readable here. Let's see here what happened here. What topic equals Amazon? So let's see what happened there. So it outputted the correct answer, but for some reason, let's see if all right. So for some reason, this time the query is not working. However, it did output. It queried the database, and it found the most recent news article for Amazon with the topic relevance score. It outputs the URL, the time published, and then also has the banner image here. So yeah, so that time it didn't work, but let me see if I could just use this example here. So basically, I take the banner image, and what I'm doing is I'm just going to plot the image out using matplotlib, and we're going to use this as the check. And for this part, we're going to actually use a different library, the Hugging Face Transformer. They also have an open source multimodal model, and we're going to leverage their agent. This here takes a little over a minute and a half. So what I would actually like to do is, Matt, if you could demonstrate ChatGPT's latest model. I actually don't have beta access, but Matt does. So while we're waiting for this to complete, Matt, if you could play that real quick, I'll stop
Sure,
sharing
I'm going
my
to take
screen.
over from.
Go, Matt.
Here it is. Yes. All right, let's see here. Where are you? Here it is. One of the lucky few that got access this week.
So as you could see, you could post an image, ask it a question, and it will return whatever you ask it. I mean, I've seen a lot of other demonstrations of the application already, and it's pretty amazing. And this is just a good demonstration of what the closed source OpenAI multimodal model looks like. And I can't wait until they release an API where we could actually use that. But in the meantime, let me show you a Hugging Faces model here. What I have here is basically something very similar. And I've logged into the Hugging Face API using my API key. I'm going to go ahead and create the agent. And what I'm going to do here is ask it just to caption the image I showed you earlier, which is right here. All right. So let's go ahead and just see if it can describe that image. It knows to use the image captioner. And it's going ahead and captioning the image. It says this right here, which is pretty accurate, except it looks like it's hallucinating here. It says the caption is a man holding a white piece of paper and a mag. And what we're going to do now is take that. Yeah, take that and pass it to our 11 Labs API to take that text to speech. And that's basically what we have today. So you just take each of those pieces and you can combine that into an app that makes sense for you, whatever you're building. But it's basically taking multiple LLMs and combining it into one. You can use like LangChain, chain them together. But in conclusion, we went over a lot of really cool things here. Basically, we were able to handle transactional and analytical workloads with your vector data. You didn't need to move data to an external vector database, really making it for a much better developer experience, as well as faster because the data is not moving anywhere. Single Store actually was able to do vector functions very quickly because it uses SIMD processor instructions, which is really optimal for vector type of operations. Also, we really talked a lot about the semantic cache layer, which you could use right in a Single Store and leverage that plan cache for more responsiveness for your queries. And then there's also external functions in Single Store that you could use with your own native code, whether it's Python or something else, and you can connect that, whether it's making embeddings and run functions directly on your data. So you don't necessarily have to write everything in SQL. You could have your Python functions have that run in something like a Lambda or in another environment and just run an external function on that. And there's a lot more exciting features that we're releasing soon. You'll learn more about that in the Single Store Now event in October 17th in San Francisco. I'll be attending, and I would love to meet you guys in person. With that, I'll pass this back over to Matt for questions.
Yes, thank you, David. We have way more questions than we could ever answer in a few minutes, but keep the questions coming. We will try to answer everyone's via email, even if we don't get to it today. And FYI, David and Madhukar, you also have Eric and Akmal. If you want to delegate any of these questions, we're welcome to. So first question I'll give to you, David. Can you please let us know your source for the news sentiment?
Yeah, it's using basically all of the company news, the stock ticker data, the news sentiment, that all came from the Alpha Advantage API. And basically, when you try to run this notebook, you sign up for Single Store, run this notebook. There's a section where you have to enter your API keys, and you would need basically API keys for all, the different libraries that I used. So it's all right there.
Awesome. This next one I'm going to give to Madhukar. It's saying, I'm not sure why I can't use Milvus, Pinecone, etc. When most of the latency is in calling the LLMs. Why Single Store?
Yeah, I think that's a good question because it came in twice, maybe from the same person or two different people. But let me address this here as well. So when you're working with vectors, you have three choices. You can use a vector-only library, which is free, and you can use Face. You can use NSLB, or you can use Annoy, which is from Spotify. All free, runs in your memory, but it only does vector, no DR, no database capabilities. Option 2, you can go to Pinecone, you can go to Milvus, you can go to ChromaDB, you can go to Superbase, and every other database now has vectors as well. The issue with vector-only database, maybe it works for your use case, is it only does vectors. So you have to store the vectors in Pinecone, and it has a limit to the metadata of 40 KB. That means you would have to then figure out the vector, look at the metadata, go back to other database to see where that file is stored or where that text is, then come back, and then you re-rank it, and then you send it back. So you've just lost 3, 4, 5 seconds, and it's also very expensive. The difference with that and single store is single store does rows, it does SQL, it does JSON, it does geospatial, and of course it does binary and vectors. That means in one single SQL statement, you can join all that data, look at that metadata, re-rank it, and do a dot product, and you can also do a keyword match, and it comes back to you in milliseconds. That's the difference between using single store versus a vector-only library or vector-only database.
Good stuff. I'm going to give this one to Eric if he's still online and available. This one is, can you give a quick high-level overview of your high availability features such as RAC, sharding, etc., that are built into the hosted version of Single Store?
Sure. So Single Store is a highly available platform. It's based on a distributed architecture. So data is sharded across multiple nodes, or sharded is another way of saying partitioned. And so a database will have some number of partitions, and there's 2 copies of each partition stored on 2 different nodes. And data is replicated between a primary partition and a secondary partition in real time. So when you commit an update to a primary partition, it's hardened on the secondary partition. So if you lose any, if you commit a transaction, it's guaranteed to be atomic and can tolerate a loss of any single node.
Good stuff. David, couple questions about, I guess, the specifics of your demo. There was one where they said, what do you mean by agents? Another where they said, what's the name of your model? The current Hugging Face one. I'll start with that.
Yeah, so agents are just basically, think of it as like different tools used to work with LLMs. LangChain has a number of different agents that can interact with the LLMs, whether it's a database, whether it's a PDF. So that's what I mean by agents. There are multiple different companies that are developing different agents. For the Hugging Face one, where I was asking it questions for the image, I was using the HF agent as well as the OpenAI agent.
Cool. Here's one. I'll give it to you, David, but unless Madhukar wants to chime in. We've gotten this on a couple different webinars. How does all of your database entry get read by OpenAI when we have a limit of 16K as per your Turbo GPT 3.5 model? So I think the question is about token limits and whatnot.
Yeah, I could actually take this. There's a number of strategies to go around the token limitations. The 16K one that I'm demonstrating here indeed is 16,000 tokens. There are models like GPT-4 that go up to, I believe, 40,000. But you could basically find ways to like summarize the data into smaller chunks so that you reduce the number of tokens. Let's say you have like a huge book and you want to really summarize one chapter. You could take that one chapter, send it to an LLM, and just ask it the question like, hey, give me the main points, and it'll be able to do that. And then you only need a lot fewer tokens for the next request. So that's like one way to kind of summarize your chunks and reduce the token limits.
So just to add to that, thanks, David. I actually wrote an article about it on Medium. There are quite a different strategies. Also to evaluate your context, there's a library called Ragas. If you just search for it, on GitHub. It'll evaluate your contextual data. And then, of course, David talked about using single store for caching. So that is also for performance. But when it comes to the token strategy, there are basically two or three. One is you can chunk up your entire document into each paragraph, and you could have a chunk overlap. And then you could summarize each paragraph using LLM and then create one embedding for that entire summarization. The other strategy is you chunk up all of the paragraphs. Then for each paragraph, you create an embedding, and then you assimilate all that embeddings later on downstream as well. So there are two or three different ways to do it. You can check out that article. There are a few good ones that people have written as well. And the other thing I will add is the number of tokens are going to increase for the LLMs. I'm saying this because I saw this in the last few months. Claude 2 now supports 100,000 tokens, which is like a massive textbook. So I'm assuming that even OpenAI is going to support a lot more.
Good stuff. I think we got room for one or two more questions before we announce the AirPods winner. Madhukar, I'm going to give you this one, but you're welcome to hand it off. Is there any REST API for single store like it has for Pinecone? Can we integrate this with no-code apps?
I will say a few things and then I'll hand it over to the professor of single store, which is Eric Hansen. I would say we have CRUD level APIs, row-based. And at the same time, what you can also do is, so that was one question, right? Whether we have APIs or not. What was the second part, Matt?
Second part was, can we integrate this with no-code apps?
Yes. So we did one webinar with Flowwise. Flowwise is a no-code app for LangChain, and you can create multiple different flows and then deploy them as an API endpoint on something like render.com. And we have two connectors in there, just like Pinecone or Milvus within Flowwise. So you just drag and drop and then put in your credential and you're off. But I'd love to hear Eric also talk about APIs as well.
Sure. Yeah, we are integrated with LangChain. So if you're comfortable developing in there, you can use that, and has interfaces to single store to store and retrieve vectors. We have a data API. So if you Google for single store data API, we have an HTTP based API to communicate, with single store to do, basic put, get, and simple queries. But, the world is full of applications that build on top of SQL relational databases. And we have like the data API, or just the regular Python, connector for single store works just the way that works with other relational databases, through the Python SQL Access API. And it's really convenient way to program. And so whatever language you're using, we have data APIs or SQL APIs that make it pretty easy to do that.
Awesome. Madhukar, I'm gonna announce the AirPods winner today. Would you mind bringing up the last slide in the deck, the single store now last slide? And I will announce our AirPods winner. So today's winner goes to Amay Patel, who is an engineering leader at Apple, who lives in San Jose, California. Congrats. Thank you for joining. If that's not you, don't give up. We're going to announce one more AirPods winner by the end of today for anyone who has tried out David's demo today. I put a link in the chat earlier. You're going to get a link via email. One last call here. As mentioned, Single Store is sponsoring discount codes for this audience to the Real-Time AI Conference in San Francisco. It's on October 17th. You can grab your $25 discounted ticket right now in the next minute. That will still be available. All you need to do is click that link. I put it in the chat. It's bit.ly AI Conference webinar discount, and you enter Single Store 25 during checkout, and you can get that marked down, usually $199. You can get it for $25 right now. Thank you to everyone for joining us. Awesome presentation, David. Thank you, Madhukar. Thank you, Eric, Akmal, and thank you to everyone for joining us. Have a great rest of your day.